The aims of this webinar, I'd like to talk about the performance of the software industry. It's a big enough industry, and what do we publicly know about its performance? And then the big question is, because it's a very strange performance, not like that you would expect from any other industry, really, why do we get this performance? And as the performance is really not all that wonderful, especially from the customer point of view, when you look at the data, how might customers use software contracts and metrics to get better performance? The webinar is based on a paper I published in IEEE Software at the end of 2010, which is referenced at the end of the slides. And although the main argument is in line with that paper, there's an awful lot of additional data which I've got, which I've added in. So the case for my arguments, I think, are stronger than they were even when that paper was written a couple of years ago. I'd also like to say at the outset that I am really quite critical of the software industry and its performance, at the same time as being astonished and admiring of its products. I mean, the world has changed through the efforts of the software industry, and it's amazing, those effects. But nevertheless, looked at from the customer point of view, as a service supplier, it's not very good. And I'm not anti the software industry. I just take the side of its customers. The first of all thing I have to say is, what do we actually mean by the software industry? It's actually quite difficult to define. It accounts for a few percent of world gross domestic product, between 1% and 2%. But actually, that's not the whole story, because there's an awful lot of software that is produced inside organizations which doesn't get separated out into industry statistics. Software that's embedded in defense systems and in games and so on, and is not actually counted as software output. So it might be that in measured in other ways, it's more than 2% of world GDP. It's a big industry, and it's relevant to bear this in mind for some of the points I'm going to make later. The study has to exclude organizations that don't usually publish their own performance data. I can only use that which is published for general consumption, and the major hardware and packaged software suppliers don't publish their own performance data, not surprisingly. And there's a lot of real-time software, particularly in defense and in appliances and so on, for which there's no published data. What I draw upon is the data from publicly available sources, which is mostly about the performance of business and government application software, and increasingly now more embedded software, as in telecoms and chips and so on. A few other remarks about the scope of this talk. I don't make a distinction between in-house or outsourced or external software suppliers, though really my target is more, I suppose, the external software suppliers, for the simple reason that if you are perceived as an internal supplier not to be performing very well, you very rapidly get outsourced. I'm also not going to deal with any exemplars. There are plenty of papers that get presented at SEPG conferences and the like, and stories from benchmarking companies who tell you they've got clients who've improved their performance and all the rest of it. I'm not interested in those. I'm interested in the software industry as a whole, because that's where the data is available from that is really interesting to explore. And the last other small remark is that I will use the waterfall model as a way of helping explain what's going on, but my conclusions are not dependent on that, and I'll refer back to the Agile model as we come later on. I've used the word industry performance, and these are the parameters that I want to deal with. The first is, these are performances measures that are relevant to customers, particularly in software contracting. The first is obviously delivery to time and budget, and then project productivity, which is size or the amount of software delivered divided by effort, and project speed, size divided by duration, and then quality, which can be measured by post-delivery defects, for example, divided by size, defect density. So size is clearly a critically important measure of work output for the software industry, and I will be referring to that quite a lot. Delivery to time and budget ought to be the norm for any service industry as in any other industry. So that's clearly we have to take those measures as rather important. The other three measures are important because they can be traded. You can speed up a project by adding more staff to the team, and that will have a detrimental effect on productivity and so on. And it may, if you have to meet a particular deadline, you may skimp on testing and you may have poorer quality. So the other three performance measures can be traded. You might also say performance is very much concerned about meeting objectives and the effectiveness of the system. But then measuring effectiveness is, or rather achieving the goals of the system and measuring how effective the project has been, is really the sole responsibility of the customer. The supplier can't do much if it delivers according to the requirements and the customer doesn't exploit the software properly. So we can't measure effectiveness very easily, and not in a way that generally can be made benchmark. And anyway, it's only the responsibility of one party. I am interested here in these measurements, these measures, I should say, because they are the responsibility of both customer and supplier. They ought to be interesting to both customer and supplier, and they can certainly be dealt with in contracts. So the first of these is delivery to time and budget. And if you have, most of the people listening, I guess, will have come across Standish chaos reports at some time or other. This picture will be very familiar. The first three pie charts on the left show in red the proportion of failed projects, in orange the proportion which were more than 10% over budget, and in green the proportion of successful projects. And the Standish Group has published studies now going on for 20 years, and the proportion of failure rate has varied between about 15 and 24%. There was a big study of European Union projects, I should have said software projects developed within the European Union a few years ago, 214 projects, about $1.5 billion worth total investment, and they show a typical 25% failure, 25% were more than 10% over budget, and so on. There's a very detailed UK public sector report on 105 outsourced projects, a total value of about 50 billion US dollars, and 37% of these projects were terminated. 57% had cost overruns averaging over 30%. And whereas the first two sources have been criticized because they haven't described their methodology, it's not clear where the data came from and all the rest of it, this third report is very detailed, and all the data is available and so on. So in spite of the first two having a bit of a question mark over where did the data come from, the three studies all report a pretty poor performance on this delivery to time and budget. More recently, last year, the ISBSG, the International Software Benchmarking Standards Group, did an analysis of the projects that were submitted to its repository and found that more than 20%, found that almost 40% of the projects were more than 20% over budget. They obviously don't get project data submitted for projects that failed, so it only deals with projects that were over budget and successful. And that orange segment or yellow segment there of projects which were more than 20% over budget is in sync with the sources with the data from the other sources. Though ISBSG did note that the trend of delivery to time and budget was improving over time. The Standish reports do not show any such trend. So let's just mention one other report which came